Hello everyone, this is Vasishta from Aerobi section. Today I'm going to explain about thermometry in engineering thermodynamics. So, what is a thermometry? Thermometry is a process of measuring temperature. Temperature is basically a measure of the amount of kinetic energy particles possesses. Nowadays, there are many different types of thermometers. For example, glass in tube, thermistor, thermocouple, radiation thermometer, etc. Thermometry is sometimes split into metrological studies in two subfields: contact thermometry and non-contact thermometry. Thermometers measure their own temperature, not that of surroundings, except if they're in thermal equilibrium, as they can never be complete thermal uniformly at large. Thermometry is always associated to a heat transfer problem with some space-time coordinates of measurements given rise to time series plots and temperature maps profiles if one-dimensional. So, basically thermometry is a measuring of temperature through a device which is known as thermometer. We have many types of thermometers nowadays. And coming to temperature meteorology is a science of measuring in comparison a physical magnitude with an agreed unit from the magnitude. The result of measuring has three elements: the unit used and the two multiples or division of a unit between which the sample sits. For example, the mass of a given book is between 1.23 and 1.24 kgs. That is equivalently the three elements may be the unit, the best estimate value and uncertainty. However, it is customary to implicitly assume that the uncertainty is just half the value of last significant digit quoted in the value, which is handy practical simplification but can be pedagogically misleading. How many university students give nonsense results like 123.4.56 Kelvin for adiabatic combustion temperature, for instance? So, the history of a thermometry and thermometers. Thermometers are the oldest of the group. The need to measure and quantify the temperature of sometime started around 150 to 150 AD with a gallon determined the complexion of someone based on four observable quantities. The first actual thermometer was in air thermoscope. Up to 1841, there were 18 different temperature scales being used. Sprites of wine were eventually replaced by mercury. For better linear rate of thermal expansion, his calibration techniques was known to be certain mixture of the melting point of a mixture of sea salt, ice, and water, and the armpit temperature of a healthy man as a calibration point. The two main calibration points used were boiling point of water and melting point of ice. About 1740, Andrew Celsius proposed the centigrade scale. It's not clear who invented the scale, but it is divided the range of a melting point of ice to steam point of water into 100 parts. Hence, centigrade linears inverted the scale so that 0 was the ice point and 100 was the steam point. Then soon enough, the centigrade scale was renamed to Celsius scale. So thermometers are generally used from long ago on a 150 AD. So the general thermometer is in which it measures the temperature of an human body when it is kept under armpit. So those were the days in which they used to calculate or they used to know the temperature of a human body. So what is the principle of thermometer? The basic principle of thermometry is it includes the main principle is that it is used to is it that of an apparent thermal expansion of a liquid use. It is difference between the volumetric reversible and also thermal expansion of a liquid in which it is a glass container that makes it possible to measure temperature that to make sure that mercury won't evaporate at room temperature easily. and inert gas like argon and nitrogen are filled above mercury. So this is a main principle included behind the thermometry, in which it is an apparent thermal expansion of a liquid. The difference between the volumetric reversible thermal expansion of a liquid in a gas container gives us the temperature. So this is what the principle of thermometer. So we have some applications regarding thermometry. So in which where we use the thermometer or temperature on which thermometer is used. Temperature is one of the most measured physical parameters in science and technology, typically for process thermal monitoring and control. But thermometry is not only applied to measuring temperature for thermal control, but as an indirect measure of many material properties like thermal capacities and enthalpy changes, relative humidity by means of wet bulb and dew point temperatures, thermo-optical properties and other radiation characteristic, for example, the radiation budget of a planet, etc. So, in which the in daily usages we use temperature and thermometry in daily uses. For example, if you want to calculate the global warming of an earth, we need a specific type of thermometer in which it calculate the temperature of an earth core. And temperature plays a major role on day-to-day life of measuring physical parameters for a science purpose, on which thermal monitoring is also an important thing to consider while having a thermometry with the temperature. So we have many type of thermometers. So as we come to see what are the types of thermometers we have, thermocouple and RDA and also IC thermometer, etc. And coming to the type of thermometers in present computer age, thermometers may be grouped in electrical and non-electrical, which are seldomly used in practice. We describe here the most used thermometer starting with an old liquid in glass familiar type, in which we can see the in olden days we have a glass thermometer with the mercury inside it. When the increase in temperature makes the mercury rise, so that we used to get an temperature readings by that liquid in glass familiar type thermometer. So there are also chromophoric substances in the shape of sticker, labels, pellets, crayons, liquid crystals, and so on, which changes color with temperature variation either reversibly or irreversibly. In information process diagrams, standard symbols and labels are used to represent different types of instruments and signal processing. Thermometers are tagged temperature transducer as a pressure transducers are labeled PT and fluid flow meters FT. So coming to the thermocouple thermometer, this is a type of thermometer in which it produces a voltage when one spot has different temperature from the set reference temperature at another spot. This is done by use of two non-similar conductors. It can also work backwards and produce electricity from a temperature difference. So it has other practical uses too. Thermocouples have the ability to work without an external power source. However, they aren't as accurate as most thermometers. So the working principle of a thermocouple thermometer includes that it is based on Seebeck's principle, in which it states two conductor and exposed to temperature voltage can be produced. This is done several times to get a reference which can then be used to calculate temperature at given voltages. So platinum resistance thermometer or RTDs, one of the many devices that measure temperature. This is one of a unique for its use of stable ductile level and also platinum wire, which is called platinum resistant thermometer. The technology can offer a device that shows sensitivity and range. Working of an RTDs or accurate readings are given with the when the wire is pure, as it gets constant proportionality between change in temperature and the change in resistivity. Therefore, when current passes from we can get the voltage of voltmeter, then calculate resistance. Now we can make the graph of a derived equation on calibration of determination of temperature. Thermistor. This is the mostly used thermometer in daily life. A thermistor works on responding to dynamic temperatures and producing resistance accordingly. Much like a simple electrical resistor, it shows negative proportionality and has a negative temperature coefficient. Since thermistors are made from semiconductors, their resistivity decreases with temperature. Thermistors are regarded to be highly reliable and sensitive. As is spoken earlier, the working of a thermistor is sensitive to temperature. So when temperature changes, resistance on this changes. When it is then used to determine temperature. The graph shows an exponential curve, so gives a more sensitive over all small temperature changes. And ice thermometer, integrated circuit temperature sensors, in which it is a semiconductor device which produces an output current proportional to the absolute temperature of a device when any voltage is applied. The device acts as high impedance constant current regulator with a typically 1 U response with a 0 to 100 degrees Celsius range with an internal external circuits. They are cheap and insensible to electromagnetic noise on the base of current mode. So as we can see, we have ear IR thermometer, 2D rate IR unit, handheld industrial IR unit, and some internal details in which the comparison among this type of thermometers can be seen with the thermocouple, RTD, thermistor, and infrared. As we can see, we have range, accuracy, size, linearity, difference, junction, etc. So this is all for my explanation on thermometry. Thank you.